Hello everyone, welcome back to my channel Quick Learn by PP. Today we'll learn about few theorems of the set theory. We have already discussed the basic of set theory, Venn diagram and the Cartesian product in my previous videos. I'll put the links of these videos in the description box. If you want to go ahead to recap on those topics, please go through those videos. So let's start. Okay, so the first theory or the first law will discuss about the transitive law. So if A, B and C are the set where A is a subset of B and B is a subset of C, then it implies that A should be a subset of C. This theorem says that subset relationship is a transitive. Now, the next law is a very important law and that has been used multiple places where we are going to prove the equality of the two set. Now, what is the law? If A, B are the set where A is a subset of B and B is a subset of A, then A has to be equal to B. Now, the next rule is that associative rule. What is the rule? So we'll do A union of B union C, that has to be equal with A union B, and then we'll do a union with C. So the next rule is identity rule. Now if A is a non-empty set, then if we do a union with A with a null set, then which equal to null set with union A and which indeed equal to the set A. So that means if we want to do a union with a empty set with a non-empty set, then it will return to the same non-empty set. Okay, the complement rule. The complement rule will tell you that if U is the universal set, then A union A complement will comes to the whole universal set, where A is a non-empty set. Okay, the next rule is the null rule. Null rule is tell about if EU is the universal set and A is a non-empty set, then A union U is the whole universal set. Idempotent rule. So what is the rule is that if A union A is always to be A, where A is a non-empty set. Cantor set theorem. So this theorem is a pretty much famous theorem, and we'll prove that theorem in one of the lecture. So now the rule says that if S is a finite set, the cardinality of S is strictly less than the cardinality of the power set of S. Now the next theorem is De Morgan's rule. Now this is a very important rule and we're going to prove that rule in the next slide. So what is the rule? If A and B are non-empty set, then A union B complement is equal to A complement intersection B complement. So the next is that we'll prove the De Morgan's laws. So what the laws is tell about, if A and B are the non-empty set, then A union B complement is equal to A complement intersection B complement. So let's take X belongs to A union B complement. That means X doesn't belongs to A union B. So that means F doesn't belongs to A and X doesn't belongs to B. That means X belongs to A complement and X belongs to B complement. And that means X belongs to A complement intersection B complement. And that means we started with X belongs to A union B complement and we ended up with saying that X belongs to A complement intersection B complement. That means A union B complement is a subset of A complement intersection B complement. So we'll prove the opposite one. Now let's x belongs to A complement intersection B complement. That means x belongs to A complement and x belongs to B complement. That means x belongs to or x doesn't belongs to A or and x doesn't belongs to B. That means x doesn't belongs to A union B, and that means x doesn't belongs to A union B or x belongs to A union B complement. Now we started with x belongs to A complement intersection B complement, and we ended up with proving that x belongs to A union B complement. That means A intersection A complement intersection B complement is a subset of A union B complement. Now with the proof two proof we have done so far, A union B complement is a subset of A complement intersection B complement, and the reverse one is that A complement intersection B complement is a subset of A union B complement. So as you know the rule subset rule, if A is a subset of B and B is a subset of A, that means A equal to B. So this too means A union B complement equal to A complement intersection B complement. So we'll end up this lecture over here. We'll come up with the next lecture with a few basic example of set theory, few practical example of set theory, and how to resolve few of the set theory problems in real life, and the uh, aptitude or common problems. Um, Thank you so much. We'll end up the session over here.